Fusion Mobile, quality e-learning experience on the go.
In this section of Physics Clinic of Fusion Mobile Nigeria, we'll use few minutes to discuss electric charges. Referring electric charges and structure of matter, we can say that static electricity may be defined as electric charge at rest. When a charge is at rest, we consider it an electrostatic, and it has some effect on matter even though they are not in motion, as we have in current electricity. Charges can be produced by friction, contact, and electrostatic induction. The gold leaf electroscope. When you hear the word an electroscope, it's a device used in measuring small quantity of charges. I would like you to bring out your textbook now and go to the diagram of the gold leaf electroscope. It's a device that comprises of the brass cap, the insulator cork which holds the brass cap down, the metal case with glass windows, brass rod, thin gold leaf which causes the deflection to make us understand when there is charge and when there is no charge. Conductors, insulators, and semiconductors. Let us take them one. Conductors. In referring to conductors, these are materials that allow easy flow of electric charges because the energy gap between the conduction band and the valence band is very small. What do we mean by that? In conductors, for example, if this is the conduction band, that means what we can consider as a workshop, and somewhere here is the valence band, that is the parking stall where we pack the charges. This particular gap here is very small, such that electrons can move easily from here to this point, and when that happens, they can move easily crossing over. When electrons are moving from the valence band to the conduction band, they conduct electricity. While insulators, this particular energy gap also is very large, such that electrons cannot move from the valence band to the conduction band. Now in semiconductors, the energy gap is not too large and is not too small, and they are not overlapping. Yes, it's small, but it's not overlapping, just like in conductors. In conductors, it seems that this is just a general overlap. There is a mixture between the conduction band and the valence band. It's as if they are married together. But in semiconductor, it's small, yes, but there is no overlap. So in normal condition, semiconductors cannot conduct. But when you add a little energy, example, thermal agitation, causing it to come up to a higher temperature, electrons can now run over from valence band to conduction band, and that time semiconductors will conduct. So that is why we consider semiconductors as an intermediate material between the conductors and the insulators, while insulators has no free electron, so cannot conduct electricity, while conductors have an overlapping conduction band and the valence band, so the electrons move easily from valence band to conduction band, so they can conduct electricity easily. The next thing we're going to talk about now is the magnets. We're going to talk about is the magnets. That's the magnetic field. But before then, I would like you to take up this homework now. Pick up your textbook and read how we can use friction to produce charge, and how charges can be produced by contact, and also electrostatic induction. And also give me a wonderful diagram of a gold leaf electroscope and tell me the function of the brass cap. When you're through with that, we move over to magnetic field. Thank you.